Hello dear friends, we are going to talk about the components of STL, that is algorithms today. Previously we had gone through the videos of associative container, derived containers, sequential containers, which is the very first component of STL. Now algorithms, as we are known, these are generic functions which handle the common tasks such as searching, sorting, comparing and editing. More than 60 such algorithms exist to operate on the standard template library. These are not member functions, nor they are friend functions, but they are function templates. To use them in their program, you have to include the header file, that is algorithm. As per, there are different categories of algorithms like retrieve or non-mutating. Non-mutating means they cannot be modified. Mutating algorithms, which are used for modifying the data inside the container. For searching and sorting inside the data, you have searching and sorting algorithms. For like binary search, bubble sort, quick sort, these type of algorithms are directly available in standard template library. For set operations, you have the category of algorithms, that is set algorithms like set insertion, deletion, that is set union, set intersection, set difference. Relational algorithms as per equal, not equal, less than, greater than. So all these types of algorithms are also available in the category of relational. So there are 5 categories of algorithms. One by one we'll see in the details of each and what are the functions which are there in these category of algorithms. For example, non-mutating algorithms means they cannot modify the data. So for example, search function which searches a desired element from the sequence to count how many number of are there in the count the number of value in a particular range. Count if returns the number of elements in the range which satisfies the condition. To check whether the two ranges are equal or not, you have equal function. They just check whether it is equal or not, but do not modify. Then to find the position of the desired element again, then find the element in the range which satisfy the conditions, and mismatch function which returns first position where two ranges differ. Wherever the two ranges will differ, that mismatch function will return. Second type of algorithm is mutating, which modifies the any of the container data, like copying of sequence of elements, copying one data elements of one container into another container. That means you are modifying the another container. So for copy, fill function, swap function, reverse, remove, that is remove function, a unique function which removes the consecutive duplicates in the range. So these functions are mutating algorithms. Third category is searching and sorting, like sort function which uses quick sort elements to sort it, because quick sort is considered to be the best algorithm. Then you have heap, merge heap, sort heap, which finds the minimum element, max which finds the maximum algorithm. Then binary underscore search, there is directly function which is available for binary underscore search, that is a binary search on sorted elements. Now we'll see an example of all these functions, and we'll come with set in the set operations or set algorithms further. To see how these are used, we include the header file, that is algorithm. We have taken vector, two vectors, one vector which is of integer b and vector p which is again of type integer, and push back elements like 10, 20, 10 in vector b and 60, 40, 50 in vector p. And then just by making the use of swap function, swap algorithm, we are writing swap v comma p. So all the contents of p will go into v and v will go into p. Just a function swap, and that happens. So this is how this function you can use. Again, you can use a find function. Suppose if I want to find 20 inside my range of A, that is an array, I directly write find A comma A plus 6 means from 0th position of array A to the 6th position I will find whether 20 exists in my list or not, or in my array or in vector or not. So that find function can be used as an algorithm. Now second number, to sort also, if you can observe that this particular sort function is there. The sort function is used as an algorithm which directly sorts the array up to the limit whatever you have specified. Okay, so this is about the algorithm functions using searching and sorting. Now the sorted list, for I is equal to 0, I less than n, you can display the sorted list which is available. Now for example, for finding or searching or finding binary search, that is for a binary search example, you again include the header file algorithm. We are taking a vector. Now in my function which is integer I comma integer j, I just take whether I is less than j. If I is less than j, I will return 1. If I is not less than j, then I will return 0. So accordingly, if I is less than j, it will return 1. Here I have taken two integer arrays, one which is 1 2 3 4 5 4 3 2 1, and next 5 4 3 2. When I am taking a vector b which is storing all the elements of the my integers array, and an iterator to iterate through that particular vector. Now next I have directly used the sort function v dot begin v dot end, means inside my v itself vector I am having these elements 1 2 3 4 5 4 3 2 1. So I am sorting my array, vector array, and then from v dot begin to v dot end I am searching that 3 is found at what position. So I am using find from begin to end. I am searching 3 value. Then I am using binary search function. I write search v dot begin v dot end, and from my vector beginning position to my end position, if I want to find a range of the elements, my integers s, it will give me the position where it has been found. Okay, so this is how I am using the search function. Then I am using binary as search. Suppose if I want to find again 3, but I want to search it using binary search, I will write binary underscore search v dot begin v dot end, means inside my vector, and will give I want to find element 3 from beginning to end position, and whether it is available or not. If it is found, it will display that it looking for 3 has been found. If it is not there, it will give not found. And then I am sorting my elements using sort function. Then I am again using binary search to find whether 6 is available or not. Since 6 is not there in my vector, it will display that looking for 6, but it has not been found. So this is the way I am using the sort and binary search function. Now if I want to find the minimum and maximum in my thing, I use directly algorithm, and I use min function and max function or max algorithm. To write it min 20 comma 10, it will give me the minimum value, that is 10. From minimum a comma b, again max e comma f. So accordingly it will display the output. So here it observe that min a comma b, minimum is b, so it will return b. From max e comma f, e is max, that is why it is going to return e. So accordingly min max algorithm can be used. Now the next is that if you want to use set operations like set union, set intersection, so how to use it? You have to again include the header file algorithm. I am taking two arrays, first and second array, and I am taking a vector v which is storing 10 elements and an iterator which is going to iterate through it. Then I am sorting my first elements, like they are not in sorting order, so I am just sorting it using sort function. And then second also I am sorting using sort function. My second array was in descending order, but now after sorting it will be in ascending order. Now after that I am doing what? Set underscore union, means I want to combine the first as well as my second vector. That is why I'm writing first comma first plus 5 means from first I want to copy 5 elements, from second I again want to copy 5 elements, and it should begin from the vector should begin from the first position, that is 0. So again I resize my function, and since there are only 5, 10, 15, 20, 25, 30, 40, 50. That means there are 5 plus 4, that is 9 elements. So these 2 elements are remaining not there, that is why it will give 0, 0. But so using resize function, I can resize it, that is the last 2 zeros can be truncated, and accordingly the output you can observe. So union, that will show that v dot size means a union has 8 elements, and the vector will using the iterator you can use it v dot begin v dot end up to the iterator and see what are the set operations. So only one function you have used, set underscore union function. In that set underscore union function you have given from the first vector from array from where to where you have we have to copy, from second array from where to where you have to copy, and from which and when you are copying it into a vector, that vector should start from what position. So that we have given using set underscore union. A set underscore intersection means what? The common which is there will be deleted. So when I am taking this, again observe the similar process as you have done previously. When I am using set underscore intersection function, what it is going to do, it is going to show that my intersection has only 2 elements. That means it has removed, it has taken only those elements which are common in both of the vectors, that is 10 and 15. So 10 and 20. That is why it is giving 10 and 20. So this is the set intersection example which is there. Set difference, again the similar thing is set difference means the one which you are finding in if you are writing set difference first minus second, the ones which are common in first and second, only those will be seen. So 5, 15 and 25 will be observed here. Okay, so this is an example of set difference. So this was the algorithm which we had seen. As for your example, you can see how different algorithms can be used for the performing the operations in just a single line of code. Thank you so much, and we'll see for the next video of iterators tomorrow.